Materials. Materials of daily use. We wear suitable cloths according to the climatic conditions. We wear cotton cloths in summer and woolen cloths in winter to protect us from cold. These are made of different fibers. Different types of fibers. Clothes like cotton, silk, wool, and jute are made up of natural fibers. Natural fibers are thick in appearance. Cloths like polyester, terylene, and acrylic are made up of synthetic fibers. Identification of natural, artificial fibers. Collect cloth pieces made of natural and artificial fibers. Burn the pieces of cloth together with the help of tongs. When natural fibers are burnt, they burn and turn into ash. When silk fibers are burnt, they give a smell of burning feathers. Wool does not burn quickly. Fibers like nylon, polyester, terylene, rayon are synthesized from chemicals. They give out odor similar to burning plastics and they shrink. Activity 2. Observation of thread in different variety of cloths. Take out the threads from different cloths. Observe threads from each cloth with a magnifying lens. Observe the thread whether it is of equal thickness throughout its length. Activity 3. Durability of cloths. Collect threads of equal lengths from different cloths. Hang the threads by fixing one end to a hook, the other end to a plate as shown. Increase the weight until the thread break up. Repeat it with all the threads. Artificial threads are strong and they are more durable. Differences between natural and artificial fibers. Natural fibers. Natural fibers like cotton, wool, silk obtained from plants and animals, whereas artificial fibers like rayon, nylon, polyester are synthesized using chemicals. These are not even in size. Strands are not too long. Artificial fibers, these are even in size. Strands are long. Natural fibers are non-durable. Artificial fibers strong and durable. Natural fibers absorb more water quickly and takes long time to dry. Artificial fibers absorb less water and take short time to dry. Natural fibers coarse on touching, whereas artificial fibers soft and smooth when we touch it. Natural fibers turns into ashes on burning, whereas artificial fibers shrink when burnt and gives the smell of burning plastic. Natural fibers heavy in weight. Artificial fibers light in weight. Natural fibers loses color easily. Artificial fibers long-lasting colors. Natural fibers wrinkles form when they get wet. Artificial fibers no formation of wrinkles when they get wet. Natural fibers. Cotton. Cotton is the best amongst all other fibers. It is obtained from the cotton balls. The long hair-like fibers on each seed are called lint. Cotton is spun into yarn. Cloth made by spinning on handlooms is called khadi or khaddar. Gandhiji used to wear khaddar cloths. Cotton cloths give comfort to the body in summer. Production of cotton fiber. Generally, cotton balls are picked by hand. Fibers are then separated from the seeds by combing in the mills. This process is called ginning of cotton. Spinning. Simple device used for spinning in the houses is a hand spindle called takli and charka. The process of making yarn from cotton fibers is called spinning. Weaving. The process of arranging two sets of yarns together to make fabric is weaving. Weaving of fabric is done on looms. Some looms which are operated by electric motors are called power looms. Silk. We wear silk clothes on special days like festivals and functions. Silk is obtained from the cocoons of the silk moth. Silkworms are reared in silk industries. Worms are kept in bamboo trays along with chopped mulberry leaves. Worms eat mulberry leaves and spin cocoons. Silk thread is obtained from these cocoons. Wool. We wear woolen clothes in winter to keep our body warm. Wool is obtained from the fur of the sheep and some other animals. Wool fiber is elastic. Threads from fiber plants. We use ropes, strings, bags in our everyday life. We get all these from plant fiber. Some of these fibers include jute fiber. We store rice, sugar in gunny bags. These bags are made up of jute. Jute is mainly cultivated in India. The stems of harvested plants are immersed in water for few days. Stems become rot and fibers are separated. These fibers are spinned as threads and ropes. This process is called retting. Coconut fiber. Coconut fiber is obtained from outer layer of coconut fruit. Flax. We get this fiber from the stem of the plant. Flax fiber is used to prepare ropes and papers of good quality. Different types of matter. We use different things in our daily life. All these are made up of matter. Matter occupies space and has weight. Matter is formed by a group of molecules. Molecules are the smallest particles of a matter which are not visible to the naked eye. Attractive forces are there in between these molecules. These forces are not same in all. Intermolecular attraction is responsible for the change in the states of matter. Three states of matter. Solids. Molecules are very close to one another in solids. Distance between molecules is very less. Force of attraction between molecules is more. So, the solids have definite shape and occupy space and volume. Liquids. Liquids are those which have the capacity to flow. Example, water, milk, oil. They occupy space but have no definite shape. If we pour water into a container, it takes the shape of the container. Molecules in liquids are not closely packed as in solids. Force of attraction between molecules in liquids is less. Therefore, they move freely and can flow. Liquids occupy more space. Gases. Gas cylinders in our houses are filled with compressed gas. Molecules of gas in a balloon are also compressed because they are loosely arranged. Force of attraction between the molecules is very less in gases, which enables the molecules to move irregularly. Hence, they do not have definite shape. Examples of gases are smoke, air, oxygen and hydrogen. Elements, mixtures and compounds. Elements. Substances formed by the homogeneous atoms are called elements. All the substances are made up of elements. Nearly 118 elements are discovered so far. Example, carbon, iron, sodium are the elements in solid state. Elements in liquid state are mercury, bromine, etc. Elements in gaseous state are nitrogen, oxygen, hydrogen, etc. Metals, non-metals. Elements are divided into two groups, namely metals and nonmetals. Carbon, oxygen, chlorine, bromine, iodine, sulfur and phosphorus are examples of nonmetals. Copper, silver, gold, mercury, calcium, magnesium, lead, iron are examples of metals. At room temperature, except mercury, all the metals are in solid state. Mercury is in liquid state. We can change metals like iron, copper, tin, aluminium into sheets or wires. If that, metals are malleable. Metals are flexible. Malleability of the metals decreases in this following order: gold, silver, copper, tin, lead, zinc, iron, nickel, etc. Electric current can pass through the metals. Conduction of electricity is not same in all metals. It may be high or low. Copper, silver and aluminium are good conductors of electricity. Compounds. Substances whose molecules consist of two or more different types of atoms are called compounds. For example, water molecule. Compounds in solid state: sodium chloride, copper sulfate, iron sulfide. Compounds in liquid state: water, carbon tetrachloride, alcohol, etc. Compounds in gaseous state: carbon dioxide, sulfur trioxide, hydrogen sulfide, etc. Mixtures. The combination of two or more substances without losing their natural characteristics are called mixtures. Homogeneous mixtures. The constituents in homogeneous mixtures are completely soluble. They cannot be identified. Example: salt water. Heterogeneous mixtures. The constituents in heterogeneous mixtures can be identified. Example: muddy water, stones in rice. Separation of mixtures. 1. Decantation. When the heavier component in a mixture settles down after water is added to it, the water is removed from the container to the other by the process of decantation. Take a glass of water and pour some sand into the glass and stir it. Now separate the water into another container without disturbing the sand. The two constituents are separated. 2. Filtration. Take a glass of water and add some mud. Take a filter paper and cut it into circular shape. Fold it as shown. Take the funnel and make the inner walls of the funnel wet so that when we put the filter paper into it, it sticks to the inner walls of the funnel. Now, pour some muddy water into the filter paper. Then, the mud particles settle on the filter paper, which is placed in the funnel, and the clean water enters into the beaker through the holes of the funnel. The dirty particles present on the filter paper are called residue. Clean water collected into the beaker is called filtrate. Evaporation. Common salt which is used in our daily life is obtained by evaporation of seawater. This salt water is let into the tanks. By the heat of sun, the salt water in the tank evaporates and salt is left as shown. Solutions. Homogeneous mixture of two or more components whose composition may be within certain limits is called solution. Example: 1. Salt and water. 2. Copper sulfate and water. 3. Sugar and water. Salt plus water gives rise to salt solution. Copper sulfate plus water gives rise to copper sulfate solution. Sugar plus water gives rise to sugar solution. In a solution, component which is more in quantity is solvent, which is less in quantity is solute. Solvent plus solute gives rise to solution. Water plus salt gives rise to salt solution. Solubility. Maximum quantity of solute that dissolves in 100 ml of solvent is called solubility. Solubility depends upon the attraction forces of solute and solvent items and also depends upon the temperature. If the temperature increases, atoms move irregularly and freely. Therefore, the solute dissolves more in the solvent.